In this section, we're going to take a look at trigonometric functions of any angle, anywhere around the circle. In the last section, we saw that sines of trig functions depend on the quadrant. In this section, we're going to investigate a connection between the angles in different quadrants. So if you take a look at the sine of the angles 20 degrees, 160, 200, and 340, all of these, if we type them in the calculator, the trig ratios for each of these are the same, except they're negative when we take the sine of 200 and the sine of 340. So what we're going to take a look at is angles on the circle in terms of a reference angle. So the signs of the function values agree with what we would expect. Sine is positive in quadrants 1 and 2, and it's negative in quadrants 3 and 4. Important thing to notice is that all the numerical values, disregarding signs, are the same. And the reason is that these angles have something in common called a reference angle. So the important definition, the reference angle labeled theta with a subscript ref of a given angle theta is the positive acute angle formed between the terminal side of theta and the x-axis. What does that mean? The first angle is 20 degrees. That's already acute, and in the first quadrant, it forms an angle of 20 degrees with the x-axis. The second angle, 160 degrees, that lands over here, if its reference angle is this acute angle made with the x-axis, is 20 degrees. 200 degrees, which is here, has a reference angle of 20 degrees with the x-axis, and 340 degrees has a reference angle of 20 degrees. So notice there are three angles that have a reference angle of 20 degrees. The fourth angle is 20 degrees itself. So for every acute angle, for every reference angle, there are actually 4 corresponding angles around the circle. So our practice, express each function in terms of the reference angle. All right, so the first one, the sine of 165 degrees, it helps me to write these or to draw these. So draw your coordinate system. We start with 0, 90 degrees, 180 degrees, 270 degrees, and then all the way around the circle is 360 degrees. So 165 degrees is here. So what angle does that make with the x-axis? Okay, so number 1, the sine of 165 degrees, the reference angle is equal to 180 degrees minus 165 degrees, which is 15 degrees. The cosecant of 345 degrees, the reference angle, we have to figure out where 345 lands. So if we start here at 0 and rotate 345 degrees, then this is the reference angle. So we'll go from 345 to 360, so we're going to take 360 degrees minus 345. And notice it's still 15 degrees. So that's why they have these. Sine of 165, cosecant of 345 have the same reference angle. Question 2. We want the secant of 195 and then cosine of 345. 345 is the same as cosecant, so that's going to have a reference angle of 15 degrees. Secant 195 is going to land after 180 on the other side of 180. So the reference angle is 195 minus 180, which is 15 degrees. Okay? So we've expressed each function in terms of its reference angle. So what makes it positive or negative when we actually find the sine, cosecant, cosine, or secant of these, what makes it positive or negative depends on what angle or what quadrant it lands in. So now we're going to take a look at how to use a calculator to find the value of trig functions. So the nice thing is our calculator will take care of it for us. So I'm going to go to Desmos. So if you type in Desmos, Desmos also has a scientific calculator. So I'm going to go ahead and use that. You can use any scientific calculator that you have. Desmos is just nice and convenient to put on the screen. So Desmos, sine, cosine, and tangent are on the main page of Desmos. Then you have to make sure we measure things in degrees and radians. So make sure, since we're taking a look and working with degrees, make sure that your scientific calculator is in degree mode. So we're going to type in the sine of 344.57 degrees. And the answer is given right away, and we want it rounded to 3 decimal places. So that's negative 0.266. Next question, find the value directly from a calculator. So enter. We want the tangent of 149.5 degrees. So we click on tangent, 149.5, and we're given negative 0.589. So using a calculator to find the value of trig functions is nice and easy when you have the degree measure and or the radian measure and you want to find the trig function. When we're going the other direction, using a calculator to find an angle given the trig function, it's a little trickier. Okay, so we're going to take a look at an example 6 from your textbook. Given that tangent of an angle is equal to 2.050 and the cosine of that angle is negative, find theta between 0 and 360 degrees. All right, so there's a function on your calculator that will allow you to find an angle given the tangent. So we'll go back to the Desmos calculator, clear out what we have. And these are under function. If you remember from the triangle section, they're inverse sine, cosine, and tangent functions. So if the tangent is 2050, then we have to find the inverse tangent of 2.050. Yeah, go back to the main page, 2.050. And we get an angle rounded to the nearest tenth. Actually, it rounds to 64 degrees. Okay, so the inverse tangent of 2.050 is equal to 64 degrees. Okay, but we want our angles between 0 and 360, so there's one of them. (64 degrees). We also need a third quadrant angle. So there's another angle. Oops, that's an angle. So there's another angle down here that has the same reference angle of 64 degrees. I'm only looking in the first and third quadrant because the tangent is positive in the first and third quadrant. So this angle, 64, also has the same tangent, 2.050. So to figure out what that angle is, it's 180 degrees plus another 64. So this picture shows that it's also at 244 degrees. Okay. So the required angle where we also want where the cosine is negative. So in the first quadrant, the cosine is positive. The cosine is negative in the third quadrant. So the only angle that checks for us, the required angle, is 244 degrees. Okay, so these are going to take some thought because there are more. When you go around the unit circle, if you're trying to find an angle and you're given a sine, cosine, or tangent, there are two places, two angles that have that same tangent. There are four angles that have the same reference angle, but two of them are positive and two of them are negative. Let's look at another example. Okay. So let's say given that the cosine of an angle is negative 0.1298. Find the angle between 0 and 360 degrees. All right, so since the cosine is negative, it's either a second quadrant angle or a third quadrant angle. Remember the sine chart from before. Using the 0.1298, we find the inverse cosine. We're finding just using the reference angle, 0.1298, and looking at the positive. The calculator tells us that the reference angle is 82.54 degrees. So I'm going to draw that, 82.54 degrees, not to scale. So where else, where do we find other angles between 0 and 360 that where the cosine is negative? Well, the cosine is negative over here in the second quadrant. So the reference angle here is 82.54. So we're going to take 180 degrees minus 82.54 to get this value, because cosine is negative in the second quadrant. If we want the third quadrant, this reference angle of 82.54 degrees, we're going to take 180 plus 82.54. And we end up with two different answers. The two solutions are 97.46 degrees and 262.54 degrees. So how do you know whether you're supposed to add to 180 or subtract from 180? Draw the picture and you can see what happens. So in this second quadrant, cosine is negative. Third quadrant, cosine is negative. So draw your picture so you can see what happens. All right, practice exercise. Try example 4 and see how you do. It's just exactly like the example 7 that we just did.